Hello. I'm going to talk to you today about hydrogels, but before I begin, I'd like to start a little experiment. I'm going to put some water in this cup, and I'm going to put in a few pinches of hydrogel, which looks and feels a bit like sugar. Okay, stir it up, and we'll come back to this later. The reason I'm talking to you about hydrogels is because the world faces a food crisis. A growing population means more mouths to feed. Climate change is causing massive droughts, and it's expected to get much worse. Topsoil erosion makes it harder to grow food, and food scarcity leads to high prices, which leads to social unrest, as we saw recently with the Arab Spring. And that leads us to hydrogels, which were developed in the 1960s by the United States Department of Agriculture. Technically, hydrogels are cross-linked hydrophilic polymers, or polymers that are really good at holding on to water molecules. More practically, they're a superabsorbent material that can hold hundreds of times its weight in water. You can think of them as little tiny super sponges. The goal of the USDA in developing hydrogels was to help farmers grow more food with less water. But it didn't work out that way because there were some problems. Turns out that the hydrogels they developed were toxic when they broke down in the soil. They were expensive, and they didn't last very long. But they did find some applications for this new material. The first uses were sanitary napkins and disposable diapers. They also came up with many other applications, including flexible contact lenses, other biomedical applications, and it was even used and is used on a small scale in some gardens. But large-scale agriculture remained elusive. Then in 2008, Dr. Nai-Hung Lee came up with a new formulation for hydrogels. And this new formulation was inexpensive, non-toxic, and in fact has been certified by the EPA, lasts for dozens of rain or water cycles, and is easy to apply. You put it in the soil at the same time that you apply seeds or fertilizer. He helped form a company called M-Oasis, and the company began working with UC Davis and Cal State Fresno to perform field trials on a variety of crops in California. And here's a sample of the results they obtained. For broccoli, the hydrogel-treated side yielded 34% more broccoli using 25% less water compared to the broccoli crops that didn't use hydrogel. For lettuce, the hydrogel-treated side yielded 76% more lettuce when irrigated fully. And for tomatoes, the hydrogel-treated side crops yielded 45% more tomatoes using 25% less water, and yielded about the same amount of tomatoes compared to the control crop when irrigated with 50% less water. So why do hydrogels help grow more food with less water? Let's start with 2 seeds, and let's put hydrogel on one side. Now we'll irrigate both sides. And in sandy soil, much of the water runs down past the plant and into the ground below. But hydrogels capture the water and fertilizer and hold it near the plant. This allows the plant to grow more steadily. To allow continued growth, the non-hydrogel side needs to be irrigated more often. The amount of hydrogel needed is quite small, only about 10 kilograms or about 20 pounds per acre. And the cost of the hydrogel is low compared to the increased value of the crop and the water savings. Other benefits of hydrogel include it helps reduce topsoil erosion and it allows farmers to use less fertilizer. So what's next for the company? They're exploring field trial opportunities in other water-stressed countries. They've begun pilot deployment with commercial farmers in California, and they plan full-scale deployment in 2014. Let's see how our experiment's doing here. So the water has turned to gel. Yeah. So with this breakthrough, it means that hydrogels can finally go from diapers to helping put food on dinner tables around the world. Thank you.